Okay, it's LeetCode Day 6, and today we're going to be tackling products of array except self. And the problem states that given integer arrays nums, return any array output where output at I is a product of all the elements of nums except nums at I. Each product is guaranteed to fit in a 32-bit integer. So our goal for this video is to solve it in O time without using the division operation. So if we look at nums, we have 1, 2, 4, 6, and basically it's just saying if you're at index 1, you should multiply 2, 4, and 6 to get 48. If you're at index 2, you get 1 times 4 times 6, which is 24. If you're at 4, you get 1 times 2 times 6, which is 12. And then if you're at 6, you get 1 times 2 times 4, which is 8. Um, that's the whole gist of the problem. And it's kind of hard to not do this without using a double for loop. So your brute force algorithm is a double for loop at O(n) squared times complexity. Um, just just making sure that I does not equal j, um, and sort of looping through the whole array twice to make sure the product is correct and isn't itself. Um, but to do this in O(n), it's actually a pretty tricky and complicated solution that I found it very complicated, and I actually had to go and research and try to figure this out myself. Um, and like I think I saw one of the videos too, and I'm gonna try my best to explain it to you guys in my own words. So, what I'd like to do first, because I have forgotten this problem, but I know the gist of it, and I know how to kind of approach it now. And I know it's like you have to go from the left to the right sort of algorithm type of thing. But before we start coding, let's actually go through the how it works, like how we can come up with an algorithm, right? So what we want initially is to have um, we initially have this array, right? Like nums is going to be 1, 2, 4, 6, right? And we want to make it so that everything to the left of an index, starting from the beginning, um, everything to the left is multiplied to this value. Is then sort of this value gets replaced by everything to the left of it, right? So for 1, we're just gonna do 1 because we're gonna treat like everything to the left of the outer bounds to be 1, right? So from 1, everything outside of it will be 1. Now for 2, everything outside of it is also 1, right? And for 4, everything outside of it is 2 times 1, which is 2. And for 6, in the 6th position, we want to say everything outside of it is 4 times 2 times 1, which is 8, right? Now, this is a res array, right? So now let's do the right. So the right side would be um, everything to the right of 6, uh, which is just 1. Everything to the right of 4, which is 6. Everything to the right of 2, which is 24. And everything to the right of 1, which is 48. Now, we have these two sets where we did one from the left side, one from the right side, right? And it's produced these values. So now if you do the math here, we get to a value of 8 times, or 1 times 48 is 48. 1 times 24 is 24. 2 times 6 is 12. And 8. And that gets us this output. So that's just the algorithm that we wrote out just by literally going through um, the steps that we can take to get there, right? and just commenting it out. So now, like, the question we must ask ourselves is, how can we go from 1246 to 1128? And that's pretty much the hardest part, like translating this into code and actually just finding out the idea to do so. Um, a lot of the time, it's just kind of understanding. Uh, this is for me. This is one of the problems that I had to just find the answer for. I spent time trying to figure out how to do this in ON, because ON squared is really easy. You could solve this problem in like 0.2 seconds. I feel like I could solve it like in 1 minute, maybe, right? Like, 'cause it's really easy. But in ON, it's a bit difficult because you have to maneuver your way around um, logically, right? So let's create a res array equal to 1 times the len of nums, um, and let's then create a prefix, which is just the left side. We're going to focus on the left side right now, and we're going to go through the for loop, and we're just going to go to the len of the nums array. I need a colon there, right? So, okay, so now let's think about it. I have 1, 2, 4, 6, right? And I want it to be 1, 1, 2, 8. Okay, what can I do so that everything in the nums at I position gets multiplied to the left? Everything to the left. So, logically, we can just do um, res at the ith position equals the prefix, right? Because we know that outside of this index, everything to the left, let's just say it's 1, right? It's going to be 1. Now, how can I make sure that once I get to the 2th position, I have what's to the left, right? So let's see. So if I go 2, I need to have 1. If I add 4, so I need to do 1 times 2, which is 2. I need to have 2 in this, in the prefix value. Okay, so I need to multiply the prefix by the nums at I, right? Because we're taking, so let's just go through this. Like let's just try to visualize this too, right? So if I'm at 1, I have res at I equal to everything to the left. So I here is at 0. So we already say, let's just put that to 1, because prefix is always initialized to 1. Then prefix times equals nums at I. So prefix now is p, let's make it equal to p, is 1. Now let's move on to the next. Then we go to the next index. We're at this index now, and we have prefix already equal to 1, so we have 1, 1. And now p is equal to the actual index of um, the nums at I. So it'll be 2, right? So it's prefix times whatever the actual number is at that the original array. So it'd be 1 times 2. Because now we want to include um, sort of what's at that exact self position on the left side. And then we can move on and do this whole process continuously. Now, uh, now if you want to go from 1, 2, 4, 6 to 4, 8, 48, 24, 6, and 1, we have to look at the postfix. So that's just the the end of the array. And we have to do for loop like this. So the first parameter is going to be the start position. And the start position here is len nums minus 1, and because we want to start at the end of the array, and we want to loop till it's at the end, and we want to step negative at 1 time, so we're going to step backwards. Now, this is our postfix. So we're starting from the result at I, which we want to be equal to um, 1 to 8, we're just going to have this, and we want to multiply the postfix. So we're going to start with res at I equal to postfix. Then the only thing that changes is that postfix multiplied equal to. So we need to obviously change what our postfix is going to be, because we need the current value, right? So the nums at I here would be 6. So now if we go to the fourth position, we need what is there at the right of us, right? So it's going to be 6. So it's going to be nums at I. Right? So then we go backwards. It's like, what's to the right? It's 6 now times 4. It's 24. So now on this index we know it's 24. Right? We move on this way. But res at I must be times equals 2. I'm pretty sure. Let's see. I'm trying to rush because I'm kind of running out of time here. But let's return. So we have to return res at the end. I just took a pause to check if I was correct and like everything was sound in terms of logic. But yeah, we get to this point where we have the prefix and postfix corrected. And before we submit, I think it's gonna do as well and good to just go through this step through this process. So we have 1, 2, 4. 1, 2, 4, 6. Okay, and we want to sort of go through this array. So we have prefix equal to 1. So now we're at res at I. Res at I is all ones right now. So at this index, at the 0th index, make it equal to prefix, because we want to look at the left of whatever nums at I is. Then we change the prefix to what the current index is, which is 1. So p equals 1. Then we move on, and then we have 2. So we go to the second index, so we have 1, and then res at I is what the prefix was before, so p equals 1, so it's right here again. And now we update p. P here is 2, because in the original array we have it as 2. So we have p equal to 2, and then we have p equal to 2. So now we're going to the third index. So we have 1, 1, and the res at I is still going to be prefix, and the prefix here is 2. And the new prefix after this is going to be nums at I, and nums at I at this point is 2 times, because now p equals 2. So it's 2 times the value at nums at I, which is 4, so it's 8. Okay, and there we end the loop because we already reached the length. Now we need to do postfix. So going through postfix, this is our res array, and this is our nums array. Okay, so this goes from, we're going to make res at I times equal postfix. So we're starting at the end here. So our res at I here is going to be 1, 1, 2, 8, because we're taking the 8 and multiplying through the postfix, which is equal to 1 in the beginning. But then we change it to the actual index at the nums at I, which is 6. So now pt equals 6. Then we move on, and then we change the array at res at I to be 4 times what the postfix was. Now postfix is 6, so now the array is going to be 4 6 times 2, which is 12, 8. And that postfix is going to be the 6 multiplied by the nums at I, which is 12. So it's going to be, PT is going to be 24. And this keeps going. And then we go to res at I times equals postfix. So postfix here is 24. And 1 times 24 is 24. So 24, 12, 8. And PT equals. Now, so PT here is going to be 24 times 2, which is 48, because that's the index we're currently on. And the last iteration, we have that 48 times 24, 12, and 8, which is the output that we wanted. So we return the result at this point, because we've done both prefix and postfix. Now if we run it, we get that is accepted. We submit, we get that it has accepted. So there we have it. That's the product of array accepts self in ON time, and in a very tricky yet very clever way of doing so. The only problem with this LeetCode problem is that it's harder to do in ON rather than ON squared, but it is possible by just taking time to understand the question and going through different possible scenarios on how to achieve it logically. And this is one that I could not solve the first try in ON, so I had to literally go look it up and watch a solution and read about it and understand it and write it out, because the solution didn't even help me. And I hope I was able to sort of clearly show you how to solve it, because I wish someone would have done that for me. And as much as you can learn from a video, I also urge you to go try it yourself. Give it yourself 30 minutes, and after 30 minutes, go try this problem again on your own and see if you actually understood what you got from this video. Thanks for watching, and I'll see you back for LeetCode Day 7, I believe? Okay, see you then.